Hello everyone, my name is Kyoung-Hee Kim. I'm a professor of architecture at UNC Charlotte. Today we will discuss resiliency in the built environment and go over what resilience means in the context of architecture and why it's become such a critical consideration in design. Global warming is affecting extreme weather. As shown in the figure, global warming increases. The overall distribution of weather events shifts toward the hotter side, meaning that there are far more extremely hot days and heat waves are becoming more common and more intense. This slide explains global climate-related disasters. On the left side, it shows the economic losses reached $2.4 trillion, with 1.94 million lives lost from climate disasters during 1970 to 2021. The figure on the right highlights that climate disasters have been both extreme and deadly. The 10 worst disasters alone accounted for 19% of total economic loss and 69% of deaths. This slide illustrates a breakdown of climate disaster types during 2000 to 2019. For instance, floods and storms dominate the largest and second largest share of these disasters, followed by earthquakes and extreme temperatures. From heat waves to hurricanes of a destructive nature, our globe is getting prone to frequent and catastrophic climate catastrophes. Therefore, it is critical to integrate climate-resilient design strategies into our buildings and the built environment. This slide illustrates a U.S. map with notable climate disasters that impacted the U.S. in 2022. Numerous billion-dollar climate catastrophes occurred, ranging from severe storms in the central states to tornadoes and flooding in the south and mid-east. The hurricanes that hit the coastal regions caused massive destruction as well. The western states also faced extensive wildfires and severe droughts. Such increasing climate disasters highlight the need for resilient, protective design strategies that safeguard our communities throughout the country. So how do we respond to climate disasters? This brings us to the concept of resilience. Resilience is defined as the capacity of a system or material to return to its original state after being stressed or deformed. In other words, it is the ability to adjust easily, to change and recover to the original state. In the context of our built environment, resilience means that our buildings and infrastructure can not only withstand natural disasters, but also continue to function, recover quickly, and provide a safe environment for the people and communities. Now let's talk about a resilient architecture design approach. We can think of resilient architecture as a cycle with 4 key phases: original state, mitigate, adapt, and recover. This approach ensures that buildings can return to their original state after disruptions. The first original state is the original building conditions where safety and functionalities are well performed for users. Second is mitigate. In this phase, buildings are designed in a way that climatic impacts to the building are minimized. For instance, flood-prone areas could mitigate flooding by elevating structures and preparing porous site conditions. This proactive approach is essential for mitigating the impact. Third is adapt. In this phase, the adaptable design involves adjusting to environmental changing conditions to minimize the overall effects of disruptions during an event or over time. For example, a flooding adaptable design might use floodable courtyard or rain garden that helps delay flooding and gradually store and release water. After the flood drains away, those sites return to community use. Lastly, recover is to make sure that buildings can be quickly restored to the original functional state after a disruption. Effective recovery strategies ensure minimal downtime and maintain safety and usability of the building. Considering all these strategies ensures that extreme impacts resulting from certain climate events can be better by reducing the impact at the first place while adapting the event and recovering post-event functionality usage. To summarize, why is resilient architecture important? Because buildings can mitigate climate impact and adapt and respond during climatic disasters, not being just static structures. A resilient building remains operational during extreme events. Especially public facilities like hospitals, shelters, and emergency centers should function well in a crisis. Even in the face of misfortune or emergency, our built environment must continue to serve its essential, safe functions. Holistic design during the design process affects a resilient building through flexible spatial planning, the use of durable materials, the integration of energy-efficient systems and backup power, and so on. This video was supported by UNC Charlotte in collaboration with the US-ASEAN Smart Cities Partnership. For further inquiries, please contact Kyoung-Hee Kim at UNC Charlotte. Let's build a more resilient future together.